July 9, 1962. The night sky over the Pacific Ocean is calm. Stars are scattered across the darkness. The water is still. Nothing moves. Then, without warning, the horizon explodes. A light brighter than the sun rips across the sky. It is not a sunrise. It is not lightning. It is a nuclear bomb. Detonated in space. 250 miles above the Earth. And everything below it goes dark. This is the true story of Operation Fishbowl. The audacious, terrifying, and deeply secret program to detonate nuclear weapons at the edge of the atmosphere. A program that changed the sky itself. A program whose hidden data is still classified to this day. Let us begin. The year is 1962. The Cold War is at its most dangerous hour. The Cuban Missile Crisis is just months away. The United States and the Soviet Union are staring at each other across the abyss of nuclear annihilation. Both sides have atomic bombs. Both sides have hydrogen bombs. Both sides have missiles that can cross oceans in minutes. But the battlefield is no longer just the land. It is no longer just the sea. It is space. The Soviets have already shocked the world. In 1957, they launched Sputnik. In 1961, they sent Yuri Gagarin into orbit. The Americans are falling behind in the space race. And they are terrified. But there is something else. Something darker. The American military believes that the Soviets are developing a new kind of weapon. A weapon that can destroy American satellites. A weapon that can cripple communications. A weapon that can black out entire cities without dropping a single bomb on the ground. That weapon is the electromagnetic pulse. The EMP. An EMP is a burst of energy released by a nuclear explosion. It is invisible. It is silent. And it is devastating. When a nuclear bomb detonates in space, the EMP can travel hundreds of miles. It can overload power grids. It can fry electronic circuits. It can shut down radios, radars, and computers. It can blind an entire nation. The Americans need to understand this weapon. They need to know how it works. They need to know how to defend against it. And to do that, they need to detonate nuclear bombs in space and observe what happens. This is Operation Fishbowl. The plan is staggering in its ambition. The United States will launch a series of nuclear missiles from a remote atoll in the Pacific Ocean. The missiles will fly high above the atmosphere. And at the edge of space, they will detonate. Scientists will watch from the ground. Aircraft will fly through the blast zone. Ships will surround the test site. Satellites will record the data. The goal is to measure the EMP. To study the radiation. To understand how nuclear weapons behave in space. But the first tests do not go as planned. The first launch is called Bluegill. The missile lifts off. It climbs. It soars. And then, without warning, it malfunctions. The rocket veers off course. The safety officers hit the destruct button. The missile explodes before it reaches space. The nuclear warhead falls into the ocean. Failure. The second launch is called Starfish. The missile rises. It reaches the edge of space. The warhead detonates. But the yield is much smaller than expected. The data is incomplete. The scientists are frustrated. Another failure. The third launch is called Bluegill Prime. This time, the missile does not even leave the launch pad. The engine ignites. Something goes wrong. The rocket explodes on the pad, showering the launch facility with burning debris. The nuclear warhead is destroyed, spreading plutonium across the island. The launch complex is so contaminated that it takes months to clean up. Failure again. The project is slipping. The scientists are embarrassed. The military is impatient. The Soviets are watching. Then comes July 9, 1962. The night of Starfish Prime. The missile is a Thor rocket. It stands 60 feet tall. It carries a W-49 thermonuclear warhead. The yield is 1.4 megatons. That is 100 times more powerful than the bomb that destroyed Hiroshima. The countdown reaches 0. The rocket ignites. It rises on a column of fire. It climbs through the atmosphere. It reaches the darkness of space, 250 miles above the Pacific Ocean. And then it detonates. The explosion is unlike anything ever seen. There is no mushroom cloud, because there is no atmosphere to shape it. Instead, the bomb releases a perfect sphere of pure white light. It expands outward, swallowing the darkness. It is brighter than the sun. It is brighter than anything ever created by human hands. The light is so intense that it is visible from Hawaii, nearly 1,000 miles away. People look up and see the sky on fire. They think it is the end of the world. But the light is only the beginning. The explosion releases a massive electromagnetic pulse. It spreads outward at the speed of light. It hits Hawaii in less than a second. Streetlights flicker and die. Burglar alarms ring for no reason. Radio communications are disrupted. Television signals are scrambled. A telephone company's microwave link is knocked out. For the first time in history, a nuclear blast in space has demonstrated its ability to cripple modern infrastructure. And then, something even stranger happens. The night sky begins to glow. The nuclear explosion has released a torrent of high-energy electrons. These electrons are trapped by the Earth's magnetic field. They spiral along the field lines, creating an artificial radiation belt around the planet. And as they move, they collide with atoms in the upper atmosphere, exciting them, making them glow. The result is an artificial aurora. A curtain of blood-red light that stretches across the Pacific sky. It hangs there for hours, visible from Honolulu to Fiji. People stand in the streets, staring upward in disbelief. They have no idea what they are seeing. They have no idea that a nuclear bomb has just been detonated in space. The scientists at the test site are stunned. They expected the EMP. They expected the radiation. But the aurora is a surprise. A terrifying, beautiful surprise. And it tells them something deeply unsettling. If a single nuclear bomb can create an artificial radiation belt, what would a full-scale nuclear war do to the planet? The answer is horrifying. Multiple nuclear detonations in space would create massive radiation belts that could last for years. They would destroy satellites. They would blind surveillance systems. They would isolate continents from each other. The world would be thrown into darkness, not just physically, but electronically. Operation Fishbowl continues after Starfish Prime. More tests are launched. Checkmate. Bluegill Triple Prime. Kingfish. Each one yields more data. Each one reveals more about the terrifying power of nuclear weapons in space. Kingfish is the most powerful of them all. It detonates at a lower altitude, creating an EMP that is even stronger than Starfish Prime. The data from Kingfish is so sensitive that much of it remains classified to this day. And then, abruptly, Operation Fishbowl ends. Why? The official explanation is that the tests were successful. The data was collected. The objectives were met. But there is another explanation. A darker one. The scientists realize something. Something that changes everything. They realize that the EMP from a high-altitude nuclear detonation is far more powerful than anyone predicted. Far more devastating. A single warhead, detonated at the right altitude, could knock out the entire electrical grid of the continental United States. Not a city. Not a state. The entire grid. Every light. Every computer. Every hospital. Every communication system. Everything. And they realize that the Soviet Union now knows this too. The tests stop because both sides understand what they have discovered. Space-based nuclear weapons are not just another tool of war. They are an existential threat. They are a doomsday button. They are a way to destroy a civilization without ever touching the ground. In 1963, just months after Operation Fishbowl ends, the United States and the Soviet Union signed the Partial Nuclear Test Ban Treaty. The treaty bans nuclear tests in the atmosphere, in space, and underwater. It is the first step toward limiting the arms race. And it is a direct result of what was learned during Fishbowl. But the data lives on. The hidden data from Operation Fishbowl remains some of the most closely guarded secrets of the Cold War. The exact EMP measurements. The radiation profiles. The effects on satellites and communications. Much of it is still classified. Buried in vaults. Redacted from reports. Hidden from the world. Why? Because that data is still relevant. Because the EMP threat has not gone away. Because modern society is even more dependent on electronics than it was in 1962. And because the knowledge of how to cripple that society is one of the most dangerous weapons on Earth. The night sky over the Pacific is calm again. The artificial aurora has long since faded. The radiation belts have dissipated. The satellites have been replaced. The world has moved on. But the sky remembers. And the files remember. And the men who watched the sun rise at midnight, who saw the blood-red glow stretching across the horizon, who measured the invisible pulse that could end civilization, they remember too. Operation Fishbowl was not just a series of nuclear tests. It was a warning. A warning about the fragility of our world. A warning about the power we have unleashed. A warning that is still relevant today. Every time we look up at the night sky, every time we see the stars, every time we trust that the lights will stay on, We are living in the shadow of what happened in 1962. The hidden data is still out there. The knowledge is still out there. And the sky, calm and silent, still holds its secrets. If you appreciate deep dives into classified history and the nuclear secrets that shaped our world, subscribe to The Past Unsealed. We uncover the files that were meant to stay buried. The tests. The cover-ups. The terrifying truth about what we did to the sky. And if you want to see more stories like this, tell us in the comments. What hidden chapter of Cold War history should we unseal next? Thank you for watching.